Pandas also got some really nice features that allow us to drop duplicates within it. We can easily drop any rows where all of the values, other than the index, it ignores the index has to be unique, but ignoring the index, where all of the other column values are identical, if we want to remove those, we can do that really easily. So let's imagine we've got this data frame here. So I've just set up a little manual data frame here, just a very simple one, just so to show this. So I've got, and the way I've done this is by setting up a dictionary where the key is the column name and the value is a list of entries against that column name. You can create a data frame easily from a dictionary in one line of code just by passing it that dictionary, and it will automatically then set this up as the column header, and this is the list of values for that column header. So here we've got some patient IDs, we've got some ages and some admissions. Now we've got 3 records in here that are duplicates because they've got the same information across all the columns, ignoring the index. They've got the same information across all of the columns for the same patient. Here we've got patient 105, 876, admissions 3. That's also duplicated down here and also down here as well. So we're not using patient ID as an index here, just to point out. So if we wanted to drop the duplicates, we can do that in one line of code just by giving the name of the data frame and calling the drop duplicates method on it. And again, here I've stored that will pass back a data frame, and the data frame that's passing back is the one where the duplicates are gone, and I'm going to store that in its own data frame that I've called no duplicate omissions data frame. So it turns this into this. And by default, Pandas will keep the first duplicate and it will get rid of the rest. Okay, so in this case, it's kept index 0 and it's got rid of 2 and 3. Sometimes, though, particularly for the kind of data you're looking at, you might want to keep the last entry, because that might be, if it's in chronological order, for example, that might represent the last encounter from the patient or something like that. And you can do that very easily just by calling exactly the same method, but we just pass in an input here and we say keep equals last, and that will keep the last one instead. So if I do that on this, you can see it's kept entry 3, this one, the last duplicate entry, rather than the one with index 0. Now, that's all well and good, I hear you say, but how likely is it that we want to use that particular definition of a duplicate? It might be we don't need all of the values to be the same. It might be that there's just a certain one that for our particular data we would consider it a duplicate. So let's imagine a slightly altered version of the previous table in which we have updated. So we've still got patient 105 appearing in 3 entries, but this time the third entry for patient 105, their admissions has gone up to 4, and it might be that what we want to say is, okay, we want to remove any duplicate entries where it relates to the same admission. So therefore we only want to keep things where the number of admissions changes. So 1 entry per number of admissions. And we can do that really easily as well. So this piece of code here will do the trick. So again, we call the drop duplicates method, but this time we pass in this argument here where we say subset equals, and then we pass in a list that has the columns that we need to change in order for it to not be considered a duplicate. So in this case, because it changes between between index 2 and index 3, the number of admissions goes from 3 to 4, then it will keep 0, although we could have kept it, if we'd have said keep last, it would have kept 2. But by default, it'll keep the first one, so it's kept 0 here, and it's also kept reference index 3, which is presumably where the patients then had another new admission.